Hi, in this video we're going to look at the January 2015 Higher Paper 1 question 16, and as you'll see it's a probability question. Now we're told that Gemma has 9 counters, each counter has a number written on it. You can see that the numbers are 1 to 9. She puts these 9 counters into a bag. She then takes at random a counter from the bag and does not replace the counter. She then takes at random a second counter from the bag, and we have to work out the probability that the number on each counter is an even number. Now, one of the important things here is that we don't have the original counter replaced into the bag, so we start off with 9 counters in the bag, and on the second go there's only 8 counters in the bag. So let's have a look at how many even numbers we have. We have 4 and the rest are odd. Let's take those to one side and see what happens when we actually go through this process of selecting counters. Now, the probability of getting an even number, which is the green ones, on our first pick is 4 out of 9. So we've got 4 chances out of 9 of picking an even number. Now, if we take that even number and that disc with the even number on it and don't replace it, then what we're left with is 8 counters in the bag, and we've now got 3 even numbers and 4 odd numbers. Now, the chances of picking an even number this time are 3 out of 8. Okay, now putting these two things together, anytime you're combining probabilities of 2 selections like this, you have to multiply the 2 probabilities together. So we have 3 over 8 times 4 over 9 giving us 12 over 72 or 1 over 6. So the probability of getting an even number on both picks is a 1 in 6 chance. Now, moving on to the next part of the question, we're asked to work out the probability that the number on the first counter added to the number on the second counter gives an odd number. Well, let's look at the various ways that we can get selections from the bag. We can have an odd followed by an odd. Now, if you add 2 odd numbers, you get an even. If we take 2 even numbers and add them together, we also get an even. The only way we're going to get an odd number when we add the 2 numbers together is if we had an odd number picked out first of all and then an even, or the other way around, an even followed by an odd. So it's these 2 last ones that we're looking at. Now, you can try this with counters yourself or try to picture it in a similar way to as I did before, but let's have a look at the odd and even selection. Now, to get an odd number, we'd need to have a probability of 5 out of 9. We've got 5 odd numbers, so there's a chance of picking an odd number 5 times out of 9, 5 out of 9. That would leave us with 8 counters in the bag, of which 4 of them would be even because we haven't picked out an even one, we've just picked out an odd one. And that would then give us a possibility of getting an even number of 4 over 8. And multiplying these probabilities together and simplifying it down gives us a probability of 5 out of 18. Now, the other method by which we can get an odd number is if we first of all pick out an even followed by an odd. The chances of getting an even, as we worked out earlier on in the question, is 4 over 9. Now, if we've taken out the even number, we will be left in the bag with 5 odd numbers, 3 even numbers, so that's 5 out of 8 chances of picking an odd number. And again, multiplying these 2 together, we end up with exactly the same probability as before, which is 5 out of 18. We then have to add these 2 probabilities together in order to find what the total probability is of all the different ways that we can get this working out, and it works out as a final probability of 5 out of 9. Okay, this video probably requires looking through a couple of times just to see what's going on. I would also advise you maybe to do this with coins. You can use 9 coins with heads and tails instead of odds and evens just to see how it works, so that you've got an idea of the process that's involved here. Okay, that's all for this video. Thank you for listening.